We're looking at problem 4. We're asked to determine if this thing converges absolutely or conditionally or diverges. So remember, for these ones, what you want to first do is test the absolute value of the series to see if it converges or not. So the absolute value here, if I take the absolute value of this thing, the -1 to the n is going to go away. So I'll check 1 over 3n, which in fact you can actually write that as 1/3 of this series here, which is 1 over n, and we know exactly what happens to that. This is divergent. So again, this is the absolute value of this series that we're checking first, and that's p series. And then since that one diverges, then we have to go ahead and check the original one as well. So check this one, and we can check that one by alternating series. Get a new marker, this one's getting too squeaky. So by the alternating series test. So for that one, the an term is going to be 1 over 3 to the n. So we're going to check what is the limit as n goes to infinity of 1 over 3n. That's clearly 0. And then we want to check is 1 over 3 n plus 1 less than 1 over 3n, and that is obviously true as well. So this one converges. And so just so we're clear, what this means is that we check the absolute value, it diverged, we check the series itself, it converged. So what is our conclusion? So the given series must converge conditionally. Okay, so again, just to reiterate here, whenever you're asked to determine if something converges absolutely versus conditionally, you need to check up to 2 series. The first one you'll check is the absolute value of the given series, and that will typically be done by some kind of comparison test, possibly ratio, well, actually not ratio test, some kind of comparison test, maybe the integral test if you have to. And then if that one converges, you're done. You would just say this thing converges absolutely. If this thing ends up diverging, then you have to actually go back and also check the original series, the alternating series, and that will be done by the alternating series test. If that converges, then you have conditional convergence, okay? If both diverge, then of course the series just diverges.